I'm just going to show how how I set up my singletons in my factories to show you that they're properly initialized and terminated with no leaks. Majority of my singletons are terminated in game N, but some of them are nested within other classes and terminated within those. Such as in my centipede spawner, it takes care of its own movement collection and movement FSM, which are singletons in my case, which I had mentioned before in another sprint, but I'll show again. So for my play controller, it's gotten quite large because it was the first singleton that I had implemented, and so basically it is using the public interface of its class as a API-like interface, and it's within those static API public calls, method calls, it then accesses its instance and then the constant variables that are associated with it. And you can see here that there's a long list, such as for the data members for my game area to determine the cell sizes, and then also the wave file and things like the locations for certain sprites for the sprite strings. And moving on to the actual CPP file, you can see that I am properly nulling it at the start, but also when I terminate my singleton, I delete the instance and also set it to null. And I do that for all my singletons, but I'll show a couple more. That should cover that one. For my game status factory, I felt like it might be important to show this one because it's a vital component of my game, but also because I don't use recycling with it because I didn't think it was necessary. Rather, this is just a form to kind of clean up my code, a form of factory just to clean up my code, because there are several different types of game statuses, and a player needs access to all of those. So rather than having it just create each one in its constructor with a separate line, it just iterates through a for loop, giving a simple integer to determine in order to create all the statuses, and then that user is responsible for deleting it, so an object pool isn't necessary. And I use this in another place in my game for the input managers, which is controlled by the scene controller, because it needs to persist throughout the entirety of the lifetime of the game. And you can see that for this one, it's also a singleton, and it's just the one method besides terminate to create and return a game status. And you can see that I am properly have the constructor and big for as private methods, and the static instance method is also. And so for the factory, I am properly deleting the instance and nulling it out on terminate. And so moving on to another set of my pools, for the laser pool, or for the laser recycling factory, it's a singleton which has lasers and it utilizes a object pool, and it also has a active list. It's the only pool of my factories to have an active list, because every other factory is for a critter, and the critter's spawners maintains that list. So I think it might have fit better to have them each individually within the object pools in order to just be more, that way the lasers could be included in that active list, and I wouldn't have to have them in separate ones as a whole, but it's the way I did it. And so same thing for this one. It has its private methods, which are called in the static API-like call functions methods, and it also has a static instance method, which properly makes sure that there's only one instance of the factory at a time, and the terminate nulls and deletes the instance, and also handles its object pool. So the way my laser object pool works is it has a member for max bullets on the screen. I found that there was a lot of possibility for duplicate bullets appearing on the screen with the way that my input is received, because the multi-threaded environment and it's just multiple calls to create laser could be made before my player's field was appropriately set to prevent the spawning of more lasers. So I had to change my object pool to ensure that this didn't happen, and this is one of the active laser list was just a consequence of that, and then it helped to also allow me to recall the lasers. But the way I do it is to recycle the lasers, I simply loop through the list and then mark them for destroy, and whenever I return a laser, I remove it from the active list and push it onto the recycled list, and whenever I create a laser, I add it to the active laser list. But the way it works is, in order to get a laser, I have a check which ensures that the active list, that there are not more, that the number of bullets on the screen is less than the max number allowed, which is set in as a member of the object pool. And if there is only, in this case, no lasers on the screen, then it's able to either get a recycled bullet or create a new one. And this ensures that there's only ever one. And you can see right here that when the bullet is created, it's a node for that. The node for that laser in the list is given to the laser, similarly to how I set the a critter node for my custom critter linked list. And so, just to be thorough and show a couple more of my factories and pools, my insect recycling factory houses the pools for all of my insects, so the fleece, scorpion, and spider, and it similarly has for its public API is methods that access the particular instance of the factory for either insect that it's creating or recycling. And in the actual CPP file, you can see it has a insect pool, which is dynamically allocated, and the insect pool has, I can open that up quickly. The insect pool is what actually contains the actual derived object pools for the fleet, spider, and scorpion, and it just relays the message, whatever static public API-like method was called, it just relays the message to that particular insect pool, and registers and returns that, and initializes that in the insect factory, as you can see. And then lastly, one more is my mushroom recycling factory. You can see mushroom. So the way I did the mushrooms for my obstacle fields is that they aren't actually recycled until they're no longer needed, so when a game over occurs. And the reason for this is just, the way I do this is just by setting them to be inactive essentially and just deregistering them from the scene. So they're externally managed, and depending on the state of the game, they're either sent to be, their external management is either set for the recycle mushroom or mushroom inactive, and inactive mushroom does nothing, recycle mushroom pushes it onto the mushroom object pool stack, and that takes care of that. And so moving on to the actual implementation, you can see that I when I initialize a mushroom factory, I initialize its pool, and then on terminate, I delete that pool and also null out the instance of the singleton and delete it as well.